All right, after several starts and stops, we're finally getting ready to go here. All right, so here we go. We've got this skier. He's going to be going up this hill. Now, normally I teach this as energy before is equal to the energy after. We've got a non-conservative force in here called friction, okay? And it's quite the coefficient of kinetic friction or skis in the soil is 0.39. Now, what we're going to do is we're going to make it as if she's going flat down this hill. And there's going to be two forces, negative forces working on her. So the work is going to be negative work that's slowing her down. So she's going to be going uphill and slowing down. All right, but we're going to make it look like she's going on a regular hill and two forces are pulling against her. All right, and that's going to slow her down. So basically all we got to do is we got to find this distance to the top of the hill. All right, so if we find the distance to the top of the hill, that's not hard. And then we'll just make that. Let's just do this. Okay, so here's my skier. Oh, you need to see what I'm doing. All right, so here's my skier on this hill, 35 degrees, right? And this is 2.5 meters high. 35 degrees, here's my skier. All right, going up this hill. mg going this way. mg sine theta pulling her down the hill this way. Normal force, or mg cosine theta going this way. And the normal force of that. All right, so the sum of the forces in the y direction are equal to 0, which is equal to the normal force minus mg cosine theta. So the normal force is equal to mg cosine theta. And the frictional force then is 0.39, which is the coefficient of friction, times mg cosine theta. All right? So that's the frictional force. We've got that. Now let's just put her on a flat ground. So here she is. We've just rotated this down. So she's got friction going this way. And she's got mg sine theta going this way. And an initial velocity of 14 meters per, what was the initial velocity there? 14 meters per second. Okay? An initial velocity of 14 meters per second. All right, so the work, the net work that's going to be done on her is equal to, and the distance that she's got to go is from here to here. All right, so she's going to go this distance here, which if this is 2.5 going up and this is 35 degrees, then the displacement that she's going to do here is going to be 2.5 divided by the sine of 35. Because that's what the cosine of that is equal to. I mean, so that's, because that's that leg. And so her displacement is going to be 4.36 meters. All right? Is equal to her change in kinetic energy. All right? She's slowing down. So the net work is done by these two forces, and they're going in the negative direction. So I've got minus mg sine theta minus 0.39 mg cosine theta times 4.36. That looks like a negative number to me, is equal to 1/2 mv final squared minus 1/2 m times 14 squared. Now notice, actually, it looks like we can get all the m's to cancel. By George, I think we can. So these are all numbers here. I wish I could put you on pause. There is a way to put you on pause so I could run the numbers here. So, well, I'll just do it. What was her weight or her mass? 60. All right. So we've got negative 60 times 9.8 sine of 35 minus 0.39 minus 0.39 times 60 times 9.8 times the cosine of 35. That equals negative 525 times 4.36 equals about negative 22,900 on this side. Negative 2289, 22,900. 2289 joules over here is equal to 1/2 mv final squared minus 1/2 m times 14 squared. So I'm going to add that to both sides. So I've got 1/2 m 14 squared minus 2289 is equal to 1/2 m v naught squared, because that's v final squared. Yeah, this is v final, and this was her v naught. That's right. You knew what was going on. 0.5 times 60 times 14 squared. Oh, good. Minus 2289. This is equal to 3591 joules on this side, which is equal to 1/2 m v final squared times 2 divided by 60. Take the square root. That's an answer that looks like it's going to make sense. 10.9 meters per second. A lot of crazy stuff in that, but that's the way it works. But I just wanted to show you that you just add up the forces, force times distance. This one we laid flat. On your exam, for your exam on Thursday, it'll be something more like we're already here. Okay? We're already here. And then you just figure out what the work done is and the kinetic energy and all that. Okay? Not too bad.